karat gold, which is incredible. That means it's already 91.7% pure, straight from the earth. That is incredibly rare. That's some of the purest natural gold you can find anywhere on earth. Now the reason why it's rated 22 karat is because there are still impurities in the gold. Now the impurities are other metals like silver, copper, iron, and tin. If we can remove the impurities, we can take the 22 karat gold and make it into 24 karat, which is the purest possible state that gold can be. 24 karat is over 99.99% pure, and that sells for more money than any other quality of gold. So that's what I'm here to do. Purify the gold and pour it into a bar. But to do that, we have to melt the gold down. Gold melts at a temperature of 1064 degrees, which takes some time to build up to. So while our gold is cooking, we're going to go to the very beginning of the process. Essentially, there are three different gold mining methods. At the beginning of the gold rush in 1851 and onwards, the first method that was used here was called shallow alluvial mining, which is also known as panning for gold. That's easy. You get a pan, you scoop up some wash dirt from a creek or river, swish around the pan with some water in it. The gold in the wash dirt will sink to the bottom because gold is heavy, and it's heavier than everything else in the dirt. And once you clear off the top layer, at the bottom of the pan is your gold. That's all you have to do at the start of the gold rush. Didn't really cost you anything but your time, and you could get rich from it. However, as years went by and more people arrived here, this gold on the surface began to dwindle and run dry. And so people started going underground. But going underground gets complicated. There's a lot of water beneath the surface. To get through the water, you need pumps. To power the pumps, you need steam engines. To power the engines, you need boilers. And to power the boilers, you need men there feeding wood to the fire, keeping the water tip-top. Individuals, naturally, cannot afford or do all of that. So now you start to see the company mines arrive. They take the stage around 1860, 1861, 10 years after the discovery of gold. They start doing deep lead mining, which is the second method, deep lead. Deep lead is when you're looking for ancient buried rivers that have gold in them, and they're buried under volcanic activity, so basaltic rock, preserving these ancient rivers with gold in them. So if you can tap into them, you can make money. The third and final type is quartz mining. This is quartz. It's a rock you've all probably seen before. Now running through quartz, you can sometimes find thin threads of gold. In a chunk of quartz this big, you would probably not find any gold in there of value. But you can find what is called a quartz vein, which is a continuous stream of quartz. And those can be gold bearing. So if you can tap into them, you can make money. Deep underground, there are miners who search for gold bearing quartz. When they find the quartz, they break it up into smaller pieces with picks and explosives. But you have chunks of rock about this big. These chunks of quartz are sent up to the surface through the tower on top of the hill. That tower is called Hobbit Head, and it functions as a bridge between the surface and the mines. Once the quartz arrives at the tower, it goes to the building next door to us. That is the battery house, where the quartz is taken to be pulverized and smashed by these enormous steel hammers that bounce up and down, driven by steam, to reduce the quartz from rock into dust. That dust is then washed over special tables in the battery house. The tables are covered in copper and then mercury. The mercury dissolves the gold and absorbs it into itself. The quartz, however, is just washed away, leaving behind the mercury and the gold mixed together in now what we call an amalgam. And this is when I, the smelter man, set the picture. I am given the amalgam. I put the amalgam in a retort to cook it until the mercury boils into a gas and then escapes to a pipe, leaving behind the gold. The gold is then placed in a crucible, which is one of these special cups, and placed in the furnace. And as we speak, our gold is beginning to melt. So in a few moments, folks, I'll be taking it out and you will witness the end of this chain of events that began with gold locked deep underground as a part of another rock and ends with it collated and perfected into one single gold bar. The gold will be poured into this mold. The mold has been sitting on the flames behind me because it needs to be hot. Because otherwise, when the gold is poured into it, it would explode, which would look pretty cool from where you're sitting, but not so good for me. The gold is about ready to be poured. It's been liquid for a while, which means we're almost ready to take it out. You're going to choose the right time carefully though, because if you take it out too soon, the gold cools down too quickly. If you take it out too late, the gold burns and turns purple. Just now is the perfect time, so stay where we are, do not go into the bricks. Have your cameras ready, here we go. Now, in the short time the gold has travelled from the furnace to the bench, it has lost 300 degrees of heat, and so now, already, it has cooled back down to a solid. The gold bar here is sitting at 900 degrees Celsius. The human body does not burn at 900 degrees, it explodes into steam. And yet here we all are, sitting in this room with an object at nearly 1,000 degrees, and no one can feel it. That's because gold is a heavy, dense metal. It has a lot of atoms, and they're all packed together tightly. So that means heat and energy radiate from gold very slowly. It is excellent, though, at conducting energy and electricity and heat, which is why there's gold in your phones. It's useful in electronics. If this tickles your finger, and you were this close to the gold bar, despite the fact that is 900 degrees and would blow you up, you wouldn't feel anything more than a faint warmth. But if you touch the gold, then in less than a second, that heat would transfer to your finger. Your finger would burst into fire and steam in less than a second.
Dangerous.
Now, what happens now is the gold would slowly cool down for about 3 hours if I just let it sit there. If I do this the entire time, the heat goes into the stick, so therefore it cools down faster. But the quickest way to just cool it down is pretty easy, just some water. Okay, so now there might naturally be some trepidation before touching the gold, considering how hot it was just moments ago, but water is very effective as a coolant. The heat has left the gold bar, gone from the water, turned to steam. The steam's all gone, so now the gold is still a bit warm. We'll rinse that off. And now the last of its heat is already gone, and there you go. That's the end result. So this is 3 kilograms of 24 karat gold, which would be about 105 troy ounces of 24 karat gold. Now that it's a bar, the company would stamp their logo on it, its weight and its purity, and then the bar would be sent off to Melbourne on the back of a horse and cart, escorted by Redcoat soldiers to protect it from bush rangers and criminals who might try and steal it. So this is 3 kilograms, 24 karat gold. Have a guess in your mind how much you think it may be worth. The gold bar is valued at $300,000. So over $250,000. I'll leave you with one last fact, everyone. Sovereign Hill has had this gold bar for about 30 years. During that time, what you've seen here, we've done this process again and again and again. This gold has been melted down, poured into a bar, and melted down again over 90,000 times. Every time we do it, the gold bar is unique. Its shape, its texture, the details change every single time. This would melt down again a few more times today, and when it does, it will not be the same. So what you're looking at is something unique and something only you get to see. Thank you very much, everyone.
什么荣金表演。